So let's continue with more definitions that we're going to be using throughout the year. This one you should be familiar with, parallel lines. So parallel lines you might just remember as lines that don't touch, but it's actually a little bit more complicated than that. It's lines that lie on the same plane and they never intersect. Okay, so they have to be in the same plane. Okay, so if you think of your paper as a plane, it's a flat surface. You can draw another line on the paper so that they're both in the same plane. And these two lines, if they're going in the same direction, then they're going to be parallel. Okay? So we can give these lines a name. And if you remember correctly, we can use a lowercase letter. For example, I can call the top one M, and I can call the bottom one N. And to signify they're congruent, we can do two things. We can either put it in like a sentence and say M is parallel to N. Okay, so that little symbol right there with the two lines going up and down, that means parallel. Okay, so you read that as line M is parallel to line N. Or on the picture, you might even see these little triangles going like this. These little triangles, anytime you see two triangles on a line, that automatically means that they are parallel. Okay, so you'll see it one of two ways. You'll see it on the picture with triangles, or you would see it in under the instructions when they tell you M is parallel to N. Okay. Skew lines. Skew lines are kind of like parallel, okay, but these are two lines that never intersect, but they are not on the same plane. Okay, so that means that they are on different planes. Okay? For example, on the picture there, this line is on that plane, okay, so it lies on it. But if I draw another line, kind of coming from the top here, hitting the actual plane, and then kind of going straight down this way, like that. Remember that dotted line means that it's not really, it is there, but you can't really see it. Okay, and this is an example of skew lines. They don't touch because one's in the front and the other one is in the back. Okay, and so same thing here. If I call the top one M and this one N, line M is not going to touch line N because one's behind the other. We call it skew, and we can say M is skewed to N. In this case, there is no notation. You just have to write it out as the word skew. Perpendicular lines. Okay, so two lines that intersect and form a right angle are going to be considered perpendicular. Okay, so like for example, if I have the line on the right there, and then I draw another line going up and down, if these form a right angle, then we're going to call these lines perpendicular. Okay, and same thing, if I call that one M and I call that one N, the notation for perpendicular is either going to be by putting the right angle sign that's automatically perpendicular, or you might see this here, this upside down capital T. If you see that sign, this sign means perpendicular. Okay, so that means M is perpendicular to N. For example, one is just fill in the blank, and so we're going to put one of those three words that we learned. Are they going to be skew, are they going to be perpendicular, or are they going to be parallel? Okay. So if you look at A, line XY, I'm going to draw it for you here, but it's going to be this line on top, that line, and line TS, which is this line on the bottom here. What kind of lines are they? Well, those are parallel. Okay. And remember, to be parallel, they have to lie on the same plane. And if you look at the back wall, they're both on that back wall there. Okay. So they're both coplanar, and they're never going to touch, so they are parallel. For part B, it says, what is QT and RZ? So if I come over here, QT is the one kind of going back and forth to us, and then RZ is this line over here that goes up and down. Okay. Now you might be thinking, hey, if I continue this line, they're gonna hit right there. Okay, but you have to remember that this line's going up and down, and this line's not going up and down. This line's actually going like towards us this way and away from us that way, and these are not gonna touch. Okay, think about it like this. Pretend this is like a tree here, and there's a road behind it. Now it looks like they touch, and here's a car. Okay? It looks like they're touching, but they're not touching because the one's behind it and the one's in front, so they're not really touching. Okay? So those are going to be considered skew. They don't cross, but they're not on the same plane. For part C, WZ and RZ. So WZ is the top line up here, and RZ is this one going up and down. And they both lie on this front plane. So they are coplanar on the same plane. And they do cross and they make this right angle because it's a cube. All the angles are right. We're going to call that perpendicular. Okay, two angles that cross and make a 90-degree angle are called perpendicular lines. For part D, it says XY, line XY and line QR. So line XY is going up here and line QR is going over here. And you might be thinking skew. Okay, why skew? Because if you look at this one is on the top plane or also the back plane, and this one is on the front plane or also the bottom plane down here. Okay, but there does exist a plane. If I draw a piece of paper kind of going diagonally this way, both of those lines are on that slanted piece of paper, and so they are coplanar. And because they're on the same plane and they're never going to touch, we call that parallel. Letter E, it says line TS and line RS. So TS is going to be over here in the back, and then RS is going to be, it's going to be over here. So they're both on the bottom plane, okay? They're both on this bottom plane. So they do that on the same plane, and they also cross right here. And because that's the corner of that box, it's going to make a right angle. And we call that perpendicular. Two lines that cross and make a right angle are going to be perpendicular. Transversal is going to be a line that intersects two lines at different points. Okay? So I have the two lines up here, and so I need to draw another line that's going to cross those two lines. For example, that one right there, that red line is going to be called your transversal. Okay, so that M line, M is going to be your transversal. Once again, it has to cross two lines at different points. This one crosses on top here and the bottom there, those are different points, and they're just crossing those two lines. Notice that when a transversal intersects two lines, there are a total of 8 angles formed. Okay? And those angles form special relationships if the lines were parallel. And we'll get to this in a later section, but for today, we have to know what these the names of the relationships. Okay? Right now, they don't really have any special relationship except for vertical angles, which are equal, and linear pairs, which are supplementary or add up to 180. But once it becomes parallel, then all the angles have a special relationship to them. Okay, so corresponding angles. If you know what the word corresponding kind of means in the same place. Okay? So if two angles have corresponding positions, or they're basically in the same place, we're going to call them corresponding angles. Okay, so when we have that two lines cut by a transversal, I'm going to give you one example. That angle, we kind of look at this in pairs of angles, or I should say groups of angles. We have these top 4 angles made by these two lines crossing, and we have these top 4 angles made by these two lines crossing. And if you notice, one is like the top left of these 4 here. Okay? And so if this is in the top left, then which one over here on the bottom is the top left? And it's going to be this one here. We're going to call that angle 5, and therefore we call angle 1 and angle 5 corresponding angles. Okay? But it doesn't have to be top left. Okay, I'm going to show you another example. You don't have to copy this down, but just make sure you pay attention. Like once again, we're going to consider this one group of angles. We're going to consider that another group of angles, and I can also use this one and that one. Why? Because this is top right, and this is top right. So those are considered to be corresponding angles. Or even the bottom left here and the bottom left, those are also corresponding angles. And the bottom right angle here and the bottom right angle here is corresponding angles. Okay, and then the top left and the top left. And so there are 4 pairs of corresponding angles. Either those two, or those two, or those two, or those two. Those are all examples of corresponding angles. Okay, in geometry, you're going to hear this word throughout this section a lot. Another word for alternate means opposite. Okay, opposite. So like the opposite of left is right, and the opposite of top is the bottom. Or you could do a combination, like the opposite of top right would be bottom left. Okay. So alternate interior angles. We already went over what interior kind of means inside, but alternate is going to be like opposite. But these are going to be two angles that lie in between the two lines and are on opposite sides of the transversal. So interior, if you remember, interior is like the inside. So the two lines, whatever is in between them, we're going to consider that interior. Yeah. So alternate interior angles have to be either one of these four angles that are inside here, either this one here, that one, or the bottom here, or the bottom there. Those four angles are interior. Okay? But alternate means opposite. Okay, for example, if I pick the top one there and call it angle 3, well, this is the top left. This would be the top right, bottom left, and the bottom right. And what is the opposite of this top right? That is the bottom, sorry, top left. That is the bottom right. Okay, so this angle here, we'll call it angle 6. Those are alternate interior. They're both inside. One's top left angle, one's bottom right angle, and that's what we call alternate interior. So angle 3 and angle 6 are alternate interior. Okay, so once again, interior is everything in here, but it doesn't have to be like this top, this one here and this one here. It can also be this one, which is the top right, and what's the opposite of top right? Bottom left. Okay, so these two are also examples of alternate interior angles. Alternate exterior. Okay, so exterior means on the outside. So two angles that are not interior and are not, and are on opposite sides of the transversal. Okay, so that's the opposite. Once again, means like alternate. Okay, so remember the interior. Are these angles are in red here are the interior, because these are exterior. It's either going to be this top left angle, top right, bottom left, and bottom right. Okay, so if I just pick one of them, angle 1 up there, then this is, once again, this is the top left. So what's the opposite? Bottom right. So I'm going to call that one angle 8. We can say angle 1 and angle 8 are alternate exterior angles. Okay, now, but once again, I didn't have to pick this angle over here. I could have also picked this one, which is the top right. And what's the opposite of top right? Bottom left. Because we're not looking at these interior angles, but we're looking at these four on the outside. But this top right angle and this bottom left angle are also considered to be alternate exterior, alternate exterior. Same side interior. So once again, interior means inside, and then the same side just kind of means on the same side of the transversal. Okay, so these are going to be two angles that lie in between the two lines and are on the same side of the transversal. Okay, so for example, here are my interior angles again. So it's going to be either this one right here, this one right here, this one over here in the bottom, or this one here. We have 4 angles made, and they have to be inside, and they got to be on the same side of the transversal. Remember, this one is your transversal. So if I look at this one here on the left and this one on the left, those are considered to be same side interior. So if I call the first one angle 3 and the second one angle 5, those are both interior and on the same side or the left side of the transversal, and those are what we call
3 and 5 are consecutive interior angles.
Okay, now same thing. Okay, these are the left. I could also have picked this right angle and this right angle here, but these two angles here are going to be same side interior angles. Okay, so let's do some examples here. It says, what type of angles are the following angles? What type of angles are 4 and 8? So here's 4 and here's 8. Now notice that they're not in the inside. That makes these two angles exterior angles. Okay? And one is like on the top right and the other one is on the bottom left. And so that's alternate, means opposite, and they're exterior because they're on the outside, so they're alternate exterior angles. For B, 3 and 7, if I look at 3 and 7 here, this one and that one right there, well, those are on the inside, and they're kind of in the, remember, these are the inside, and they're on opposite sides. This is the top right angle, and this is the bottom left angle. and top right and bottom left are opposites, and therefore they're alternate interior angles. For C, angle 7 and angle 6 are these two here. And once again, these are on the inside, so they're interior, but they're not opposite from each other, but they're both on the same side of the transversal on the right side. Those are what we call same side interior angles. Okay, so same side interior angles. 5 and 7. So here's 5 and here's 7 over here. And one's inside and one's outside. So we cannot call them either interior or exterior, but you do notice that 7 is like the bottom right of these four, and 5 is in the bottom right of those four. And when they're in the same place, bottom right angles that are in the same place are going to be called corresponding. Okay, corresponding angles. 5 and 6. So if you look at these two here, 5 and 6 are both of these combined. And this is actually something we learned before. These are not alternate exterior, alternate interior, or consecutive or corresponding, but two angles that make a straight line and that are like half a circle. Remember, that's half, and then here's the other half of the circle. But that 180, two angles that are adjacent and that are supplementary are considered to be a linear pair. A linear pair. And then for F, angle 4 and 6, if I look at angle 4 here and angle 6 over there, well, those are opposite angles made by two lines that are crossing. And when they're opposite from each other like that, we call those vertical angles. And one thing we do know about vertical angles is that they are congruent. Okay, so those angles are equal to each other. The parallel postulate. So remember, postulate is a common sense rule. Even if I don't tell you this rule, or you can pause it, you should be able to figure this rule out by yourself without me telling you. Okay? But it says if there is a line and a point not on the line, okay, here's the point and here's the line, the point's not on the line, and it says then there exist blank lines passing through the point that is parallel to this given line. How many lines can I draw going through this point that are going to be parallel to this given line here in the bottom? Okay. Kind of common sense that you can only draw one line, and that line will be that one right there. Okay? Perpendicular postulate, kind of very similar to postulate. It says if I have a point not on the line, okay, then how many lines exist that are going to go through that point that are going to be perpendicular to this given line? Okay, well, same thing, common sense, and you can just kind of picture it. There's only one line, which is going to be that line right there. Okay, that's the only line you can draw that's going to be perpendicular, so we have to draw a right angle. And if I try to draw another line, it won't be perpendicular. It's going to be slanted, and it's not going to make a right angle. Okay. And last definition, a perpendicular bisector. A perpendicular bisector is a segment, a ray, or a line that is going to bisect a segment and is also going to be perpendicular to the segment. So it's basically in the definition. It's going to bisect it, and it also has to be perpendicular. Okay. For example, let's take a look at that segment. If I draw a line going like that, it's going to bisect it into two congruent pieces. That's the definition of a bisector. And it also has to be perpendicular, so it's got to go. It's got to form a right angle. That red line up there that you see is a perpendicular bisector because it cuts it in half, two equal pieces, and it's also perpendicular. Okay? So for example 3 is to sketch the following and put the correct notation on the diagram. So it says for A, sketch a line that passes through point N, so it has to go through this point, and it's going to be a perpendicular bisector of MP. Okay? And so I have to cut this segment down here into half, so I'm going to go to the middle here. It's got to go through the middle, and it also has to form a right angle. And it's got to cut it into two equal pieces. So that will be, make sure you put these little equal pieces to signify that it's being bisected. And then for B, it's to sketch a line that is parallel to NP. So NP is this line right here. And it has to pass through point M. Okay. So to be parallel, it has to go in the same direction, but it has to pass through that point M. So And remember, to signify, or the notation, is you're going to put these little triangles like that. These triangles signify that those two lines are going to be parallel.